Okay, let's kick things off. We're diving into a future that's probably closer than we realize.
Mm,
AI agents acting for us,
yeah.
managing our stuff like finances, assets, all on the blockchain.
Yeah. And the big question, the really critical one, is how do we make that safe? How do we make it, understandable?
Exactly. How do we not just blindly hand over control?
Right. We've been looking at some really interesting material that tackles this head on. It compared how different blockchains handle transactions, specifically looking at Radix's transaction manifests versus, say, Ethereum or move-based chains like Aptos and Sui.
So, our mission today basically is to unpack that. We want to get into why one approach might be fundamentally, well, safer and clearer when you've got an autonomous AI managing your digital life.
What's the secret sauce, right?
Right.
And why should you care if you ever plan on letting an AI handle things?
Let's start with the core problem the material highlights this
Yeah.
idea of blind signing.
Yeah, it's crucial. With many current systems, when an AI or even you clicks authorize, you often don't get a truly clear picture of everything that transaction will trigger.
It's opaque.
Exactly, opaque.
Yeah.
You're signing without fully knowing the consequences. Blind signing.
Which is frankly terrifying when you think about AI and your money. So let's compare. What's the fundamental difference in how these platforms handle transactions?
Okay, the key distinction boils down to the model. Ethereum and Move mostly use what's called an imperative model. You tell a contract, run this function, do this thing.
Okay.
Radix uses a declarative asset-oriented model. With its transaction manifest, you're not just saying do something, you're stating the explicit steps and the desired outcome, especially how assets should move.
Gotcha. Let's break that down. Ethereum first. Most people have probably used it. How does its model work, and what are the problems for AI?
So an Ethereum transaction is basically a message call. You're calling one specific function inside one smart contract.
Yeah.
All the logic, the asset movements, everything happens inside that function's code. And the big problem, highlighted in the source, is that the data telling the network what to call is, well, opaque,
Me.
meaning it's just a hash or encoded data. You might see your calling transfer, but you don't see the detailed steps within that function, especially if it calls other contracts.
So you trust the function name, but the actual execution is a black box.
Pretty much.
Yeah.
Take sending an ERC20 token. You call transfer. You hope and trust the contract code does the right thing, debits you, credits the other person. But the transaction data itself, it doesn't spell that out. You cannot easily discern the transaction's true intent or outcome from the payload alone,
You're just trusting the code.
entirely.
And what if the AI needs to do something complex, like multiple steps? Swap, then stake, maybe?
That's another issue the material points out. Ethereum doesn't really have a built-in way to bundle multiple separate actions into one guaranteed atomic unit. No native concept of bundling arbitrary steps atomically.
So the AI would need what? A special contract just for that sequence,
Either a custom aggregator contract, yeah, or it has to send transactions one by one.
which sounds risky.
It is, because the first step might work, but the second could fail, or get front-run by someone else, leaving your AI strategy half done and possibly losing you money.
Plus, we've seen security issues like reentrancy arise from this imperative interactive model, haven't we?
Exactly. So you've got opaque data, tricky multi-step composition, and reliance on trusting complex code interactions.
Okay. So how did move-based chains like Aptos and Sui improve on this?
Move made a significant step forward with assets as linear resources. This is a core language feature.
Linear resources.
Yeah, think of tokens or NFTs. They can't be accidentally copied or deleted by buggy code. They have a clear owner and must be explicitly handled. This inherently prevents certain kinds of bugs common in, say, Solidity.
Okay, that sounds like a built-in safety layer, a definite improvement.
It is. And they've also advanced composability. Sui, for example, has programmable transaction blocks, or PTBs.
Right.
These let you chain multiple function calls together into a single atomic transaction. So you can do multi-step operations more easily than on vanilla Ethereum.
So better asset safety and better bundling of actions. Sounds good for AI, but the material still draws a distinction with Radix.
It does. Because even with PTBs, it's still fundamentally a function call model. You're listing which functions to call on which contracts. The outcome or intent must be inferred from the function definitions and how they interact. You're still trusting the code inside those functions to achieve the result. They lack a user-facing declarative transaction format separate from the smart contract code itself.
Okay, so you're still defining the how, call these functions, and inferring the outcome, by understanding the code.
Precisely. Now contrast that with Radix's transaction manifest, which the material calls a radically different approach.
Okay, let's get into the manifest then. What is it really?
Instead of calling a function and hoping for the best, a Radix transaction is the plan. It's a list of explicit instructions for the Radix engine. It's asset-oriented and declarative.
So you're writing out the steps.
Pretty much, yeah. Like a script. To send 10 tokens, it wouldn't just say call transfer. It'd say something like, Step 1, withdraw 10 XRD tokens from my account. Step 2, deposit those 10 XRD tokens into Bob's account. You're declaring the asset movements.
And this makes combining steps natural.
Exactly. Multiple steps can be chained in one transaction without needing a custom coordination contract. An AI can script, withdraw from A, send to app B, take result from B, send to app C, deposit final result in D. All in one go.
One single transaction.
One single atomic transaction. Critically atomic, it all succeeds or none of it happens, period.
That level of explicit detail seems huge for transparency.
That's arguably the core difference. The manifest is designed to be human readable, or at least easily machine parsable.
So the AI, or maybe more importantly, your wallet, can read it.
Yes. They can understand the intent and the expected outcome. By simply reading the manifest's instructions, it spells out the plan, the intended outcome in plain terms, and the platform guarantees that outcome if the transaction executes.
So instead of trusting black box code, you declare the intent up front, and the network enforces that script.
You've got it. The material uses a DeFi example, like taking a loan then swapping. On Ethereum, complex, maybe multiple transactions, maybe a specific contract. On Move, a PTB calling functions.
And on Radix,
A single manifest. Withdraw collateral. Call lending protocol component. Withdraw borrowed funds. Call swap component with those funds. Deposit swap result. You see the assets moving between each step, explicitly listed.
wow, seeing that flow laid out.
Yeah,
Yeah, that feels fundamentally different from just seeing a function call. Much more transparent.
it really is. And the transparency and native composability, that's where the power comes in for AI agents doing complex tasks for you.
Right. Which brings us neatly to AI autonomy and composability. Why is this explicit multi-step format so important for an AI agent?
Well, because AI agents aren't just doing simple sends, are they? They're executing strategies. Move funds through multiple DeFi apps, rebalancing, yield farming, complex stuff.
They need to string actions together.
Precisely. They need to compose sequences, and the Radix manifest makes that a built-in native capability.
So the AI can just write out its whole multi-app plan as one manifest.
Exactly. Withdraw here, swap there, deposit over there, all in one atomic script. And here's a huge benefit the material highlights for AI developers. If any part of the plan fails or doesn't meet the criteria, the entire transaction is reverted.
So AI doesn't need complex error handling for partial failures.
Nope. It simplifies things dramatically. The AI knows either the whole plan worked perfectly or nothing happened, and it can just try again or make a new plan. No messy intermediate states to clean up.
Compared to, say, Ethereum, where a multi-step plan done sequentially could fail halfway, leaving things in a mess.
Right. And while Move PTBs allow bundling calls, Radix makes this multi-step, asset-aware composition native to every single transaction, described in that clear language. The material quotes Rax docs. Asset returns from one component can be directly passed on to the next, all within a single transaction.
So the AI is literally scripting the flow of assets between applications.
Yeah, it's less like calling separate programs and more like writing a detailed choreography.
And the material suggested dApps could offer instruction pieces.
Yeah, like building blocks. An AI could dynamically generate transaction manifests by picking and combining instruction pieces provided by various dApps.
So dApps expose actions, and the AI assembles them into a plan, like an API of actions.
Exactly, rather than just calling one big function. It's much more modular and predictable for the AI planner.
And can the AI add its own checks within the manifest?
Yes, that's another key aspect.
Yeah.
Manifests can include assertions, basically conditions that must be true, things like minimum outputs from a swap.
So the AI can say, only do this swap if I get at least 23 Y tokens.
Precisely. And the platform enforces it. If the condition isn't met when that step executes, the whole transaction fails. The AI gets built-in guardrails against bad outcomes.
That predictability. Yeah, I can see why that's gold for an autonomous agent. Autonomy, but with explicit instructions and guaranteed outcomes.
Which leads directly into security, doesn't it? Because if you're letting an AI manage your money, security is everything.
Absolutely. So how does this manifest model boost security specifically for AI agents?
Several layers. First, back to transparency. Because the manifest clearly lays out every action the AI will perform in advance, you or an oversight system can review the exact plan.
You see what it's actually going to do.
Right. Contrast that with an opaque Ethereum transaction. The material says this greatly reduces the risk of an AI agent inadvertently authorizing a malicious or incorrect transaction. It eliminates that blind signing.
The AI itself could even check its generated manifest against its goals, right?
Potentially, yes. It's structured data. Then there's asset control. How does the agent get permission to move your funds?
Okay, yeah. Big question.
The Radix engine requires explicit instructions to withdraw assets. An AI cannot accidentally give a dApp more access than intended, and critically, there is no need for global token approvals.
Ah, that's huge. No more of those scary, approve this contract to spend all my tokens forever pop-ups.
Exactly. That whole class of attack vector, exploiting broad, lingering approvals. The material says they're non-issues on Radix, because the model just doesn't work that way. Assets taken out must be accounted for by the end.
Okay, so no unlimited approvals. What about those assertions we mentioned? How do they help security?
They act as runtime guardrails. The AI can put conditions in the manifest. If the price slips more than 2%, abort. Or I must receive at least X amount back from this swap.
And the platform enforces this?
Yes. If conditions fail, the transaction will fail safely. This protects against bad slippage, but also makes things like front-running an MEV attacks harder. Because if the attacker manipulates the state too much, the transaction just won't execute due to the assertion failing.
That's a powerful built-in defense. But what about the AI's fundamental permissions? How do you stop it from trying to do something totally unauthorized?
That's where Radix's native role-based access control comes in, using proofs and badges. Instead of giving the AI your private key, which is all-or-nothing access, you give it specific badges.
Badges? Like digital permission slips?
Kind of, yeah.
Yeah.
You can grant granular permissions. Maybe a badge lets it trade on a specific DX component, but not withdraw funds to an unknown address.
So the principle of least privilege. Give it only the keys it absolutely needs.
Exactly.
Yeah.
If the AI tries to generate a manifest instruction it doesn't have the badge for, like that unauthorized withdrawal, the transaction will fail validation. The agent is effectively sandboxed by the permissions you gave it.
Okay, wow. So transparency, explicit asset handling, outcome guarantees via assertions, and fine-grained permissions with badges. That really does sound like a comprehensive safety net.
Yeah, the material sums it up by suggesting this model could prevent the kinds of infamous DeFi hacks we saw on Ethereum from happening via an AI agent on Radix, simply because the agent can't sign those opaque, unbounded transactions that were exploited.
Let's peek under the hood then. What technical features make this manifest system reliable enough for AI?
Well, number one is deterministic execution.
Meaning?
Given the same ledger state and the same manifest, the outcome is always the same, predictable. The engine can even simulate or inspect the entire transaction flow up front.
And why is that so important for AI?
Because an AI needs certainty. It needs to predict the result of its actions. Determinism allows an AI agent to simulate a manifest locally to predict the exact result before signing it. Plus, remember the atomicity. Everything either happens all at once or not at all. No partial states, no complex recovery needed. Then there's state validation and resource accounting. The Radix engine acts like a rigorous accountant.
A constraint machine, the material called it.
Yeah, it rigorously checks the validity of each step. Do you have the funds for this withdrawal? Do you have the badge? It tracks resources on a virtual worktop during the transaction.
Making sure everything adds up.
Exactly. By the end, it checks. All resources are either deposited somewhere or explicitly burned, and any specified assertions hold true. If anything fails, anywhere along the line, the whole thing is rejected. Cleanly.
So constant verification throughout the script's execution.
Providing a strong guarantee. If it's valid, it executes predictably or it fails completely.
What about different apps in the same manifest? Could one misbehaving app mess things up for others?
That's where logical isolation of components comes in. Scripto components, the smart contracts on Radix, cannot perform arbitrary global state changes. They only work with the resources explicitly handed to them by the manifest instructions.
So a component can't just grab extra funds from your account?
Nope. It can't suddenly take more from the user because it wasn't given more in the script. This prevents many unpredictable interactions and makes each component call more sandboxed and analyzable. The manifest defines the boundaries.
Makes sense. And this whole deterministic, isolated model sounds scalable.
Definitely designed with that in mind. The material mentions parallelism and sharding. Because the manifest declares what's involved up front, the system knows which parts of the ledger, shards, are affected.
Helping organize work for parallel processing, like with Cerberus?
Exactly. It means even complex AI transactions can potentially be handled concurrently, aiming for high throughput.
And is the manifest system itself adaptable? Can it evolve?
Yes, that's key. The material points out that Radix was designed with this upgradability and deterministic evolution in mind. They can extend the manifest language, add new instruction types for future AI needs, while preserving determinism and predictability.
So it's not set in stone, it can grow.
Right. It's intended as an extensible language of intent, a stable but growing interface between off-chain AI and on-chain execution.
Okay, fascinating tech. But let's bring it back to the person listening, you. How does all this manifest stuff actually impact your experience using an AI agent on Radix?
This is where it really hits home. The material strongly emphasizes clarity and confidence for the user. When your AI wants to do something, your Radix wallet reads the manifest and shows you that clear, itemized list of actions.
Like that example, withdraw 50 ERT, borrow 100 XRD, swap for USDR, deposit USDAT. You see all those steps.
Exactly like that. Not some cryptic hex code or a generic interact with contract message. You see the plan. You can quickly grasp the intent and hopefully spot anything weird before signing. The claim is this significantly boosts user trust.
I can definitely see that. What about the hassle of approvals, that approve then transfer dance?
That's the reduced approval friction. Because the manifest handles the withdrawals needed for the transaction right there in the script, there is no need for separate approvals.
And crucially,
no risk of broad lingering approvals left open to exploit later.
so it's one signature for the whole multi-step plan, and it's safer because there are no leftover permissions.
That's the idea. One transaction instead of two. Simpler and inherently safer.
What if the AI's plan hits a snag? How does the error look to me?
Failures are atomic and reasonably interpretable. Remember, it's all or nothing, so no confusing half-done states. And often, the system can tell you why it failed. Assertion X was false, insufficient funds. Your wallet can relay that information clearly.
Better than just random error code.
Much better than what the material calls a potential nightmare for UX. You get either success or a single clean failure with a reason, and everything rolled back.
And can I set my own rules for my AI agent?
Yes, that's the empowering user controls part. Because the manifest is structured data, your wallet can analyze it before you sign and apply your policies. Like, flag any transaction sending more than 1,000 XRD to an address not on my safe list, or require extra confirmation if the AI tries to use that risky new protocol. Your wallet becomes an active gatekeeper based on your rules.
So the wallet collaborates with you and the AI, using the manifest as the common language.
Precisely. It enables that collaborative UX.
And for the people building these AI tools, is it easier for them?
The material suggests so. Manifests are straightforward to generate. It's like scripting. This lowers the barrier, potentially leading to more AI-powered services built on Radix that can safely act for you. Like that AI financial assistant, easier to program its actions as a manifest.
So wrapping up the UX, it's about clarity, control, and confidence, bridging the trust gap with transparency.
Making it feel safer and more understandable, especially for people who aren't deep crypto experts but want to benefit from AI delegation.
It all feels very intentionally designed for a specific future. How does this manifest system tie into Radix's bigger, longer-term picture?
Directly. It's linked to their scaling ambitions. If you want millions of AI agents running complex strategies, you need massive throughput.
Which is where Cerberus and sharding come in.
Right. And the manifest helps coordinate that because it explicitly declares what resources and components are involved, helping the network parallelize the workload across shards. It's integral to handling that scale.
So the transaction model itself is part of the scaling solution for an AI-heavy future.
Seems so. Supporting that vision of DeFi at a global scale. And it's designed to be future-proofing, right?
So.
By being extensible. The material contrasts this with legacy chains, where adding such a system would be incredibly hard. Radix built it in so they can evolve the manifest language for new AI needs, maybe new instruction types, while keeping it predictable and compatible.
Ready for things we haven't even thought of yet.
Exactly. Which leads to anticipating AI-native DeFi. New financial tools designed by and for agents. The focus on assets, intents, and even native multi-party support in manifests is seen as ideal for this.
Like that example of two AIs doing a direct swap with a joint manifest.
Yeah, peer-to-peer agent interactions atomically without needing a specific intermediary contract just for them. It's a different way of thinking about on-chain coordination.
And this all comes back to UX and security driving adoption.
That's the consistent message, especially for mainstream users relying on AI. The design aims to align with a future where your interaction with crypto might often be through an AI assistant. Trust and safety become non-negotiable.
Is the developer community engaging with this AI angle?
The material mentions community projects exploring AI, concepts like an AI agent computer interface, ACI, using Radix as that secure execution layer. Good tooling makes it easier for devs to integrate AI logic with manifest generation.
Positioning Radix as a strong contender for AI-driven apps.
That seems to be the strategic goal, yes.
Okay, so let's boil it all down. What's the absolute core takeaway from this deep dive?
The central argument we explored is that Radix's transaction manifest represents a forward-thinking interface paradigm.
Because it uniquely bundles human-machine readability, atomic composability, and built-in security guarantees right into the transaction itself.
Yeah, and those specific features align extremely well with the needs of autonomous AI agents, much more so than traditional models, is the claim.
Making Radix potentially a very conducive platform as AI and blockchain really start to merge.
The core advantage seems to be enabling AI agents to act safely and predictably, handling complex multi-app strategies in one go with clear instructions and guaranteed outcomes.
Which, for you, the user, means more confidence that your AI helper won't go rogue or get tricked.
Right, and for developers, a more robust and predictable foundation to build on.
So ultimately, the material presents Radix as treating the transaction layer not just as plumbing, but as a vital first-class user and agent interface designed for clarity and trust.
Which could be key for actually bringing decentralized finance and AI together for everyone, not just the technically savvy.
That was a really fascinating look at something that feels quite futuristic but is grounded in very real problems. How do we safely delegate complex tasks to AI in this new digital economy? And it really highlights how the fundamental design of the transaction system itself, like this declarative, asset-oriented manifest approach, could be absolutely critical for building that necessary trust and transparency.
It really makes you think, though, doesn't it? If, or maybe when, AI agents become common for managing our digital lives, investments, payments, everything, how much more important does that underlying system's transparency and predictability become?
Not just for developers, but for you, right? When it's your assets on the line, controlled by an AI.
Exactly. How do you build that trust? How do you maintain control? The design of that interface, that transaction layer, suddenly feels incredibly important.
Definitely something to keep mulling over as this tech races forward.
For sure.
And on that thought, that wraps up our deep dive for today. Thanks for exploring this with us.